Okay, so what we're going to look at today is Unit 2, Lesson 1, Characteristics of Functions. And so the first thing we want to look at is interval notation. And so we've got this table up here at the top, and we've got three sections. We've got an in-word section, a picture section, and interval notation. So in words, what we've got, well, first, interval notation is a mathematical way to represent a subset of real numbers. So it's just a way to group numbers that exist for a certain function. And so it answers the question on what interval is this existing. So if we look at this first example, all values between and including -3 and 2, we're going to have a number line and between those two values, and it includes both of them. So on my number line at -3, I'm going to have a closed circle, and it goes all the way to 2 and all the numbers in between. So we'll kind of shade all the numbers in between. So what we're saying is it is including -3, -2, -1, 0, 1, and 2. It's also including all of the halves and quarters and eighths and sixteenths and all the fractions and decimals in between those values as well. And so for interval notation, since we are including -3 and 2, we are going to use brackets. So we're going to say bracket -3, comma 2. So this interval notation is what we're going to be using when we get to the graphs. So it includes -3, it includes 2, and all the numbers in between. So the next example is all values between and not including -3 and 2. So that not including means that at -3 we have an open circle, and at 2 we have an open circle, but it's still all the numbers in between there. So that means we can have all values including 1.9999999999999, but we don't include 2. So to write that using interval notation, we use parentheses. So it gets really close to both of those values, but it never actually reaches. So then in words, we've got all values except -3. So that's every single number possible, but not -3. So at -3, we're going to put an open circle, and we're going to say it's all the numbers less than, so more negative, and all the numbers greater than, so all the 1s to 0 and all the positive numbers possible. So this one is a little tricky to write in interval notation because if we're including all values, we're starting at the smallest value possible that we never actually reach, but we're starting at -infinity. And we go all the way up until 3, but we're not including it, so we use parentheses. And we use this little symbol, it's called a union. It means it could be in this set or this other set. And so then we have all values greater than 3 until positive infinity. And so we use parentheses at the infinities because technically speaking, we can never actually reach infinity. So we've got 2 pieces, it's all numbers except for 3. Then we've got all values greater than 2. So would that include 2? No, probably not. So if it's greater, we're going to shade to the right on the number line. And we're going to say from 2 to positive infinity. And then all values less than 2 would be to the left, including all those negative values. So we would say from -infinity up until 2. And so that's a real basic definition for your interval notation. Hopefully that makes some sense. And so we're going to take it one step further and we're going to talk about domain and range, and we're going to use that interval notation to figure out what our domain and range are going to be. So in this first one, we've got domain values, and you see that it's in a box and you've got left and right. And domain is all possible x values. So when we are finding the domain, we are using the x-axis. So domain is all possible x values, and we look at it starting on the left side, ending on the right side. Range is bottom to top, and that is all possible y values. So we're looking at our y-axis. And so if we work through a couple of examples, we're just going to figure out the domain and range using these graphs. So there's ways to look at functions and figure out your domain and range, but we're just going to look at the graphs to start out with. So if we're looking for domain, that is my x value. So what I'm going to do is I'm going to box in my function. So the very left side of my graph is here, and the very right side of my graph is here. So that means my domain is between those two x values. Well, we've got solid dots, so my domain is between a 1, that's a 1, and 10. This is a 1. And so for range, we're going to do the same thing. The bottom of my function is crossing here, and it stops up here. And so my y values, because range is read off of the y-axis, is going to be -2 to 6. And so that's what we're going to do. So in example 2, do the same thing, box it in. My left side crosses here, my right side crosses here. So my domain goes from -5 to 5. And my range, my y value, I'm reading it off of the y-axis, is -3 to +7. And we'll keep doing those. So example 3, I'm going to box in my domain first, reading off of my x-axis. Looks like I go from -9 to 10. And my range, go from -8 to +2. And I'm reading those values off the y-axis. So go ahead and pause your video and see if you can do the next one. You've got a heart on a grid. Hopefully you pause your video. I'm going to go ahead and work through this one. So let's see, your domain, you should have gotten -6 to 3. And your range, you should have gotten 0 to 8. If we make it a little more complicated, we get things that are a little bit more function related, a little more math related. And so in example 4, we're still doing the same thing. We're still doing our domain and range, but now we've got open circles and closed circles. All that does is it changes your interval notation, so when to use parentheses, when to use brackets. But everything else is essentially the same. And so my domain, my leftmost x value is a -1, and since that is an open circle, I use parentheses. If I can draw them correctly. We go from -1 to 3, and 3 is a closed circle, so we use brackets. And then my range, bottom to top, I want my smallest value first, so I go from -4 to +4. Here, example 5. My left side is at -2. My right side is at +2. At both of those points, they are both open circles, so my interval is going to be parentheses, so -2 to +2. And my range, we are actually starting at the x-axis, so y is 0, and I go all the way up until 4. And since I've got open circles, I go from 0 to 4 with a parenthesis. So we've got example 6, so we'll just keep plugging on along. So domain is left to right. It's my possible x value. So my graph is existing between the x values of -5 with a bracket and 5 with parentheses. My range goes from -3 to +2. And so pause the video here and go ahead and work on the next two on your own. All right, so hopefully you got those next two on your own. So I'm going to do domain and range. I'm not going to talk through it. I'm just going to tell you what my answers are. And I kind of do them both at the same time. I'm highlighting just so that we can see where, if we had those horizontal lines, if we boxed in our function, where it would cross the x-axis and y-axis. I think it helps to be a little bit visual about it. So domain for this one, we've got -3 to 5. -3 should have parentheses, 5 should have a bracket. And then my range, I've got two open circles, so it goes from -2 to +2 with parentheses. On the next one, my domain is -5 to +4, both with brackets. And my range is 4 to 5, both with brackets. So there's your domain and range. We'll make it a little more complex when we talk about some of the functions we'll learn about in math too. So things like quadratic functions, square root functions, a little bit of an inverse function. But that's your basic guidelines for domain and range. So if we look at one more thing today, we're going to use our x values and we can define intervals of increasing and decreasing. And this is using our x values. So increasing, by definition, a function is increasing when as the x values are increasing, the y values are also increasing. In other words, from left to right, the graph is uphill. So if you trace it with your finger, are you going uphill or downhill? And then decreasing, a function is decreasing when as the x values are increasing, the y values are decreasing. So we've said increasing and decreasing about 1,000 times by now, so it's probably really confusing. But we're going to do some examples. Hopefully that makes sense. So now, if we're going from left to right, the graph is downhill. So in example 7, 8, and 9, what we're going to do is just write our intervals for increasing and decreasing. And so if you wanted to, for extra practice, you could write out your domain and range. That's always a good thing to do, extra practice. But we're just going to do increasing and decreasing together. So in example 7, if I trace my function from left to right, so left to right, my function is going downhill. And so it's going downhill between the x values of my x values of -1 and 3. So it decreases the entire time. So if we're increasing, we're going to say none. And decreasing, we're going to say it decreases from -1 to 3. And those rules for interval notation still apply. So example 8, if I trace it, I make a U. I start out decreasing, going downhill. And then I go increasing. So if you think about a roller coaster, when you're going down it, your stomach kind of drops. When you go back up, your heart is racing and all that stuff because you know that another drop is coming. But at that point in between your stomach dropping and your heart rate increasing, it's not really doing anything. It's not exciting at all. So think about that as your defining point between increasing and decreasing. At that point, you are not doing either one. You're not going uphill and you're not going downhill. So on this graph, we have two pieces of increasing and decreasing. And so since we've got decreasing first, we decrease from my -2x value to my 0x value. And so we use parentheses at both of them because when we reach that 0, at 0, it's not increasing or decreasing. And then it increases from 0 until the end of your function, which is at +2. And since you've got open circles, the 2 and -2 have parentheses. So example 9, if we're rolling our roller coaster, we are going uphill the entire time. It's not like super steep at the beginning, but then it gets really steep in the middle and then it kind of levels off at the top. But it's still increasing. Your y value is going from -3 to -2 to -1 to 0 to 1 to 2. So your y value is increasing as your x value is increasing. That is your definition there. Increasing. And so it increases the entire domain. So it increases from -5 until +5, and it doesn't decrease at all. So we've got 6 more examples to get through with different kinds of graphs. So it's a little bit more like functions versus just random stuff on a graph. So it could be a little tricky. We'll work them out together. So we're going to combine everything. We're going to do domain, range, increasing, and decreasing. Domain, range, increasing, decreasing. All right, so my domain, first of all, is left to right. So my domain is from -5 to +3. My range, the lowest value is here. Tallest value is there, and so my range is -2 to 4. And then if I trace my function, I've got increasing for the first part, decreasing for a little bit, and then we've got increasing again at the end. And so remember, those are your x values. So it increases from the beginning of my domain until 1. And remember, at that 1, it's that turning point. So we use parentheses. And then it also increases in another piece. So we're going to use that union symbol. And it starts increasing again at 2 until the end of my domain, which is at 3. And then it decreases that little piece in between my increasing. So it decreases from 1 to 2. If you want to think about it, your increasing and decreasing combined together, all those intervals, should cover your entire domain. So -5 to 3 is -5, -4, -3, -2, -1, 0, 1, 2, and 3. And so we've got -5, -4, -3, -2, -1, 0, 1, 1, 2 to 3. So your increasing and decreasing should involve your entire domain. All right, example 11, we've got to use our imagination just a little bit. So since we have an arrow, that means that this graph is continuing even off of the page. So we know that it is continuing forever in this direction. It goes on forever and ever and ever. That's what it means to have an arrow. So my domain, since I have an arrow, if it's continuing forever in the left direction on a number line, we know the smallest value is actually going to be a negative infinity, but it stops on the right side at 2. So that one's kind of tricky. Haven't really seen one like that before. And my range, the bottom of the function, it's sitting on the x-axis, but it's also continuing forever in that positive direction. So it's gently increasing on my y-axis. So even though it's going to the left, it's kind of a little weird. Your y value is still getting bigger and bigger and bigger and bigger and bigger. So my range goes from 0 to positive infinity. And we start our domain with negative infinity because that's the left side. It's a smaller value, and your interval notation always goes from smallest to largest. So then for increasing and decreasing, we're going to trace my function from the left to the right. So even though my arrow is pointing to the left, we're still tracing it like we were reading a book. So left to right. So am I increasing or decreasing? Well, I'm going downhill. So I decrease the entire time. So I decrease the entire domain. So in this case, my decreasing and domain are the exact same thing. So it's still covering all the same numbers. All right, example 12. This is a piece of an absolute value function, and you'll talk a lot about those in Math 3. And so if I do domain first, my left of the function starts at -2, and my right of the function has an arrow, so I know it continues forever and ever and ever. and my x value is increasing forever in the right direction. So my domain starts at -2 and continues forever, so it goes to infinity. My range, the bottom of my function, is on the x-axis, and the top of my function, it's not over here, it's over here, because that arrow is continuing, and my y values are going to increase as that graph is still going and going and going. So my range is from 0 to infinity. And then increasing and decreasing. So I'm going to trace it with my finger. I've got 2 sections. So I start by decreasing, going downhill, and I end up increasing. So I decrease from the beginning of the domain until this x value, until -1. We use a parentheses because -1 at that exact point is neither increasing or decreasing, and then we increase from -1 to positive infinity. All right, 3 more. So domain, we got an arrow on the left side, so I know it's continuing forever. So my smallest value is going to be in -infinity, and I know it stops at +2. My range, the bottom of my function, is on the x-axis again, and the top of my function, it continues forever. So as my graph is continuing, my y values on that x-axis, y-axis are going up and up and up and up and up. So my range, we go from 0 to infinity. And then for increasing, decreasing, we're reading it from left to right. So trace it like you were reading a book. So left to right, I'm decreasing, going downhill, and then increasing. So we decrease first. So we decrease from the beginning of my domain until this turnaround point. So until 1. Remember, we're reading x values for increasing, decreasing. And then we increase starting at 1 until the end of the domain. So until 2. Go ahead and pause. See if you can do example 14 by yourself. This was kind of tricky. All right, so my domain, I've got arrows on both sides. So that means my function is continuing forever in both directions. So your domain, this is called a parabola, it's a quadratic function, is -infinity to positive infinity. And when we get to quadratic functions, we'll talk a lot more about why that domain is the way that it is. And so my range, the bottom of my function, it goes forever in the negative direction. So the smallest value is going to be -infinity, and it stops at +2. Remember, we're reading off the y-axis for range. Increasing, decreasing, if we trace it with our finger, we increase first, we decrease next. So again, you can think about a roller coaster. So you're going up, 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 and you're just waiting for the drop to happen, and then you drop. So we increase from the beginning of my domain, so -infinity, until that almost dropping point, so until 1. And we decrease from 1 until the end of the domain. So remember, increasing and decreasing together make up your entire domain. And 15 is possibly the trickiest one we see today. So let's start with domain. So since it's got an arrow, we know it still continues past where we're boxing it in at. Same thing with range. Excuse me. So we have a domain. We start at -4. And my right side of the function has an arrow, so it continues forever and ever and ever. So we go from -4 to infinity. My range is bottom to top. So this is the trick. So your bottom over here has a starting point, but here we've got an arrow. So even though this stops right here, this function over here is continuing forever and ever and ever past where this one actually stops. So my range is actually negative infinity up to 0. And that one's tricky because on the graph, it really looks like this is stopping before this side, but it's not because it has that arrow. So then if we trace it from left to right, we increase first, decrease second. So we increase from the beginning of my domain until -1, bracket at -4, parentheses at -1, and then we decrease from 1, -1, until infinity. And that encompasses our entire domain. Once you are through the notes, if you've got questions, send me an email. If not, your homework is posted on Canvas.